Hello, this is Joe Strout, and I'm going to be doing a video series, sort of live coding a little video game of a base defense style. I'm inspired by the excellent video series that Trey Tomes has been putting out lately. He's building a JRPG and some other cool things, and his videos have been a lot of fun to watch. So hopefully mine will be just as fun. If you haven't checked out his channel, definitely go check it out. I'll put a link down below. This is MiniMicro. If you're not familiar with it, I'll have a link to that as well. It's a virtual computer with sort of a neo-retro style. So you can see it boots into a blinking cursor. I'm not going to spend a lot of time on basics. We have other videos about that. I'm going to get right into making this game. Now, first let me describe the game that I'm trying to make. I have it in my head, but I don't have much in the way of sketches or anything. It's inspired by a game I found out about recently on Steam called Thronefall. And the basic idea is you're defending a base, but you have a little unit that represents you, the player. So you can move around and fight enemies yourself, but a lot of it is about setting up defenses for your base, defensive towers and economic generators and that sort of thing. The enemies come in waves, and in between waves, you get to work on your base. And then when the wave starts, you spend most of your time actually out fighting and trying to put out fires, so to speak. So this is what I want to try and create in MiniMicro. I'm going to go with a theme of being inside the computer, sort of like in Tron, and I'm going to use geometric shapes for the units because they're easy. In fact, I haven't done any coding on this project at all, but I did prepare some sprites. I did them in a drawing app called iDraw. And so you can see here what I have in mind for the sprites. And I'm thinking of using the shapes and the various iconography to indicate different attributes of the enemy units and your own units, which will just be tinted different colors. This big star here is you, the player. Triangles will be flying units. They can cross over barriers like walls and gaps. Squares will be ordinary land units. They can not cross walls or gaps. And then pentagons could be burrowing units. They can cross under walls, but they can't cross gaps. And then I also have some buildings. I have to stretch the window out in order to enable the buildings layer. Here we go. So this will be your castle that you're trying to defend with 4 turrets or towers that will be able to shoot automatically. This will be a tower that you can place, and this is the actual turret. It'll rotate on top of the tower. And then these square buildings are production buildings. There's big and small ones. And we'll either put one of these icons from the unit sprites on it to show that it produces that type of friendly unit, or we'll put a $ on it from down here to show that it produces money for upgrades and new buildings. So that's the big idea. I took each of those layers and I exported them to PNG files, which we can view here. So if I were to do view, find file, building sprites looks like this, and the unit sprites look like that, just what I had in the drawing program. So obviously in order to use this as sprites, the first thing we'll need to do is cut this up into individual pieces, or at least make a function that can pluck out any of these that we might need from the larger image. And that might be a good place to start. So eventually this program will probably be big enough I'll want to divide it up into separate files, but for now I think I'll just put everything in main. So let's see, we've freshly booted, so I can just say edit, and let's get started. Load the sprite images. Sprite image equals file.load image. And I'm going to assume the images are right here. Actually, they should be in a pics directory. And it was called BD sprites. I can't even remember. It was called unit sprites and building sprites. And also I did want to move them into a pics directory. So let's do a file.make dir pics. and then file.move, building sprites.png to pics. Yep, and then do the same for unit sprites. Okay, there they are. So building sprites and unit sprites. Unit sprite, we'll call it, it's a sprite sheet. Unit sprite sheet is that, and then unit sprite, use function, column, row, and this is going to return one of those things. Now I saw in, darn it, I have to stretch this out again to switch layers because this little inspector panel over here doesn't scroll. If I show the grid and set the grid to be, so these little squares are 8 pixels, these big squares are now 64 pixels. And you can see that I've arranged these so that these are 64 by 64 sprites. So with that in mind, we can say return unit sprite sheet dot get image column times 64 row times 64, except that in MiniMicro, coordinates go up from the bottom. Oh no, that's still fine. Yeah, I think we'll keep that. We'll keep it bottom up rows. And then the width and height. And for testing, let's see. Well, we'll just test it manually. So if I run that and I view, we'll just view find file again. So you're looking at our unit sprites. If I wanted to get, let's say this square. Oh yeah, and I forgot to explain the rest of the iconography. These units with circles in the middle can shoot ranged attacks. They can shoot projectiles over gaps, but maybe not over walls. And then I'm not sure what the lines here will indicate. Maybe some other ability that we'll decide later. Well, let's say I wanted to get this square one with the ranged projectiles. That would be row 0, 1, 2, column 1, 0, 1. So I should be able to do view unit sprite, column 1, row 2. Hey, and there it is. Cool. All right. So we got that. And then we also need to pull out the player sprite. That's a little bit different. Because it's bigger. It's 96 by 96. However, its starting position, well, it starts in the third column, so 0, 1, 2, 3. I know, it's the fourth column, but it's column 3. And then what we can do is just take it as 96 down from the top. And then we'll go 96 by 96, so that should work. So we'll do unit sprite sheet, get image, 64 times 3, and then unit sprite sheet, oops. It's getting to be too long. Height minus 96, and then the width and height are 96 by 96. And yeah, we should save this. We'll call it main. And run it. Unidentified identifier. Oh, this is interesting. So, by the way, I'm not using an officially released version of MiniMicro. Let's pretty print that. I'm using MiniMicro version 1.2.1 Final Candidate 2, which has one known remaining bug. And that is sometimes when I hit F5 to run, it inserts a junk character, and then it also runs as I told it to. Sometimes it does that, sometimes it doesn't. See, now it's fine. I haven't tracked that down yet. It's the last remaining thing I have to do before I push out this release. But anyway, we've run, and we should now have a player sprite, which we can view. Cool, we got it. Okay, now that's a bit of a misnomer though, I realized, because I'm calling these sprites, but they're not sprites, they're sprite images. So let's be more precise. But actually making a player sprite is a pretty good idea. I think a good first goal, and I'm going to try and keep this video down to about an hour, although I forgot to look at what time I started. A good first goal would be getting the player sprite moving around. So let's do that. Player, I'm just going to call it player though, because I'm going to be using this variable a lot, and I don't want to have player sprite all over my code. So just player is new sprite. Player.sprite equals player sprite image. No. Player.image, I mean. Player.x equals 480. We'll just start at the middle. 320. And then, oh yeah, we should set up the displays. So we'll start by clearing. Sprite disp is display 4, which is automatically configured by the clear command to be a sprite display. And then we can do sprite disp.sprites.push player. And now we should see it. Cool, there it is. We need a background too. Let's make a function for that. So, for the background, let's insert a color. I want a dark blue color with like faint blue line, lighter blue lines on it. So we'll pick a color blue like this, and then for X in range 0 to 960 in steps of 64. I think so. Vfx.line x0 to x 640, and then for y in range 0 to 640 and steps to 64. Draw a horizontal line. Can't type today. 0y to 960y. And then after we clear, we'll draw the background. Okay, that's not too bad, except those lines are much too bright. We'll use insert color again. Okay, I want sort of like this, only fainter. Yeah, maybe like that. All right, that looks pretty cool. Now, my player is too big. I'm going to want to scale it down by a factor of 2. Wait, well, let's just see what that looks like. Oops. It's called player, not player sprite. Yeah, that'll be better. But, you know, for now, while I'm developing this, I'll keep it bigger. That'll make it easier to see, particularly on the video. So we'll worry about the scale later. Okay. So I'm going to have the player updating. I'm going to have the various enemies updating. The buildings will be updating. There'll be a whole lot of updating going on. So I think I want all my sprites to have an update method, which we will call from a main loop. So let's do that right here. Player.update equals function. And by the way, that trick I just did, in case you don't know, this is what happens if you hold the shift key and press return. It inserts the block closer and the blank line and then puts the cursor on the blank line. So that's a little shortcut. All right, so updating. How do I want to control the player? I thought about using directional inputs like the arrow keys or WASD, or you could even use a gamepad then. But I feel like maybe mouse would be better. Maybe the player sprite should always go towards the mouse. Then you could just sort of mouse around on the field wherever you want your player sprite to go. I don't know. This is a tough call. You know what? I will use the directional inputs for now. Can always change it later. So we'll do dx equals input, no, key.axis horizontal, dy equals key.axis vertical, and let's see. We want to move, I want to do a style where whatever direction you push, the sprite turns in that direction and then goes forward. So we can figure out what direction that is. Let's see, we won't worry about moving smoothly. We'll just snap in that direction for now. So dir equals, that's what ATAN2 is good for, dy dx. And then we could do player.rotation equals dir for now. Let's get our update method called from a main loop. So while true, player.update we'll do for now. Later on we can loop through all our sprites and call update on all of them. But for now, let's try this much. ATAN2, that's not a thing. It's ATAN. I slipped into a different language for a second there. I've been doing a lot of C and Python lately, so don't be surprised if I drop some C-isms or Python-isms in there. Okay, right, then we have to remember that ATAN gives us radians and rotation is in degrees. So we'll take our dir, actually we'll take it right here after ATAN and we'll multiply it by 180 degrees per pi radians, and that converts to degrees. So there's up. Oh yeah, when there's no input at all, it snaps back. We'll have to fix that. Here's left, here's down. Oh yeah, and I should point out this little line here indicates the front of my sprite, and that was something I did on all of the unit sprites. So hopefully that'll be clear enough. I think once it starts moving around, it will be, because it's always going to move forward. So, let's see. If dx, if not dx, not dy, then return. We're just going to handle movement for now. If we have more stuff, we'll move this into a movement method, which we'll call from update. But for now, we'll just do that so we can bail out if we don't have any input. And now, instead of having the rotation go directly towards the target direction, I want it to smoothly approach the target direction. And how do we do that? I think we have to handle a couple of cases. Degrees are tricky because you could rotate either direction, right? If we're facing up and the input says go right, you could either go the short way or you could go the long way. Either way would get you there. And I think it's going to be helpful to see what's going on. So I'm going to do text.row equals 25, print dir plus a bunch of spaces, and then we'll do if, let's see, delta equals dir minus player rotation. I'm printing out the delta as well. And then we can do, let's import math-util, because that has a handy move towards method. So math-util that move towards from player rotation towards dir, and only a certain amount per frame. Let's try 5 degrees per frame. Oh yeah, and in our main loop, we forgot to do a yield so that the Main loop is limited to 60 frames per second. Save it, run it. Okay. Undefined identifier player rotation. Yeah, that's not a thing. Sometimes, right. It's funny. It's like my fingers are listening to what I'm saying. I'm typing what I'm saying, but not what I really meant. Okay, pushing down. Oh, see, there's a case where my direction is 180. And then to get to a direction of minus 90, it decreases. And that makes it go the long way around. So that is a case where it's not going the way we would want. Otherwise, it's pretty good. I can do diagonal inputs. Yeah. But it's definitely going the long way around sometimes. So what's the right thing to do here? When the direction is 180, and we're going to a negative, you know what? We just have to consider both directions and take whichever one is shorter. I think that's correct. So, okay, so the delta. So this is the dir. Let's make sure that our direction is positive first of all. So if dir is less than 0, then dir plus equals 360. Then we can get the delta. Then we could do the direction the other way. If the absolute value of delta, or of, let's see, dir minus 360 minus player dot rotation is less than absolute value of delta, then set our delta to, or our dir to dir minus equals 360. So we're going to take that 360 back off. And I know this looks a little funny to add it and then take it back off, but the point of this line is to make sure that we're always starting with a positive direction. And the point of this one is, if it would be shorter to consider it a negative direction, then go ahead and do that. And then having done that, the delta doesn't actually matter because we're using move towards dir. So I think that might do it. Let's try. So we go to the left, now we go down. Hey, it went right down. Back up, to the right. Yeah, I think this is good. Oops, no it wasn't. Hang on. I was down here, and then I pushed to the right. Oh, I'm just going all the way around. So when we're down here, our dir is 270. And then I push to the right, which is 0. Yeah, of course it's not going to be any better. Oh, did we already solve this in math-util? Nope, we have move towards and move towards xy, but we do not have move towards angle. That's too bad. That would be a handy function to have. All right. Well, we'll get it. I think that, oops, that's not what I wanted. I think we need to make a helper function. And whenever you're like, boy, I wish I had a function that did this, you should just make a function that does that. To move towards angle, just function from ang to ang max delta, or max change. All right. And then we can test this. So for now, we'll just return mathf, or math-util.move towards from ang to ang max change. But we know that doesn't work in all cases. And to test that, the QA.assert. Well, that means I need the QA module too. That move towards angle, so 0 to 90, 10. So if we're starting at 0 and we're going towards 90, we should definitely move in the short direction, which is no more than 10 degrees. So that means the answer is 10. We're going to move 10 degrees from 0. If we're going the other way, 0 to minus 90, that should be negative 10 degrees. Easy, right? But it should also be negative 10 degrees if instead of minus 90, we represented that as 270, because those are the same darn angle. So it should still be minus 10, and I don't think it will be, because Matthew Till just thinks they're numbers, and it's going to try to increase up to 270 instead. There should be another case like that. QA.assert move towards angle 0 minus 270. That would be the same as 90. So let's get the cases that are equivalent together. Now if I run this, it's gonna say program failed on line 22, which is this one. Okay. So what we got to do is we got to figure out how much change there is for each representation of our angle and the target angle. So let's get them so that they're both positive. So we're going to get them both in the range 0 to 360, and you do that by taking it mod 360. If it's negative, it'll still be negative, unlike Python, but like most other programming languages. So in that case, you add another 360 to get it into the desired range 0 to 360. We'll do the same for 2ang, mod 360. If it's less than 0, then add 360. Now they're both in the range 0 to 360, and we have two possible deltas. Let's see. If absolute value of from ang minus 2ang, no wait, what do I want to do here? Dang, delta ang equals from ang minus 2ang. If dang is less than 180, then it's a typical case, right? We've got them both in the positive range, and the difference is less than 180 degrees, so you can just go for it. But if it's more than 180, then we want to go the other way around, which would be what? From ang minus equals 360, and then do it. Let's try that. Nope, failed on line 30. Line 30 is this one, going from 0 to minus 90. All right, let's consider that. Our 2ang is minus 90, but after this line, it should be 270. Oh yeah. And our from ang is 0 here, so that would have gotten us to minus 360. And moving from minus 360 to 270 is definitely not the right thing to do. So, what do we do in this case? Our from ang is 0, our 2ang is 270. We want a negative answer. Why do we get a negative answer? 0 to 270. I'm going to end up spending most of this video on this one darn math problem. It's always something, right? Yep, okay, so it is exactly as we thought, 0 to 270. So what is the right thing to do in that case? It's our Diang would be 270 minus 0, so also 270, which is clearly greater than 180. So we want to go the other way. We just want to take the negative of the difference. No, that doesn't seem right, because it might be just a little bit, right? Our 2ang could be 359, and then we'd only want to go 1. How do we get there? Subtracting 360 from ang is not the right thing. Subtracting from the 2ang would certainly work in this case, but would it work in every case? I suspect not. I think we want to be working with Diang itself. Diang, subtract 180 from the Diang, and then move towards, let's see, from ang plus moving towards 0 to Diang, max change. Hey, passed all our tests. I should do more extensive tests, but instead, I'm going to just try it. All right, going up, left, down, right, down, left, up, right, down, up, down, up. I think it's working. All right, this is awesome. Let's get our debug prints out of here. Okay. So now we need to actually move. And I think, oops, wrong function. Player dot x equals just do a constant speed for now. Player dot x plus equals speed times cosine of, let's do it in radians, player dot rotation times, let's see, we have to convert back to radians. There's pi radians per 180 degrees, so cosine radians. Player dot y plus equals speed times sine radians. That's pretty cool. We could refine this a little bit. I was thinking of having it so it doesn't go around the corner quite so much, having its speed depend on how much it's facing the desired direction. So that when you do a UE, it doesn't do a big UE like that. But I don't know. It actually feels pretty good. The other thing we could do though is have a little bit of ramp up in speed. So speed could be an attribute on the player. And let's get this move towards angle function out of the middle of our player class. Utility functions. Okay. Just take these out for now. Okay, player.speed equals 0. So whenever the if dx and dy, or dy, then do the following, rotate the player, else, oh yes, and increase the speed. Move towards speed 5, and you can accelerate by 0.1 per frame, which is still a pretty fast acceleration. Otherwise, speed equals math util move towards from speed to 0, same deceleration. Okay, and I should have said self. You know what? All this should be self. Player dot should be self dot within the selection. Complete words. Do it. Okay. And this should be self dot speed. Self dot speed. Okay. So when you have an input, dx or dy, or both, we increase the speed. When we don't have an input, we decrease the speed, and in either case, I guess we could say, if not self.speed, then return. And, whoops, line 46, right, self.speed. And it inserted a garbage character again. Where'd it go? Return right there. Dang it. I gotta get to the bottom of that bug. Oh, it's a little bit like skating on ice now. Like inputs down and up. The turns actually look a bit better, but it's too sluggish, too skating around. So let's tweak it a bit. We want it to accelerate much faster or decelerate much faster when slowing down, and a bit faster when speeding up too, I think. Yeah, now I don't feel like I'm skating on ice. That's pretty cool. It's got kind of a weighty feeling to it. All right, checking the time. I'd say I've got another 15 or 20 minutes. I think I want to put in the castle next. Oops. So that'll be its own class. Even though this is, I mean, in classic base defense, it's always a castle, but this is a computer theme, so we might call it something else. It's probably the server or something, but I don't want to call it base class because that's confusing. You know what? Fine. Internally, at least, it's a castle. And the building kind of looks like a castle too. So, castle, just need a sprite. Castle that image. Oh. Right. We need to get the image. Building sprite sheet. And view building sprite sheet. Right. And all I care about at this point is the castle. Well, here, let's switch back to our thing. Let me stretch this out. Drawing program. Okay. These are 64 by 64 squares, and it's one of those up, and it's right against the left, and it's 3, which is 64 times 3 is 196, I think. So we'll do get image starting at 0 and 64, and then 192 by 192. Yeah, not 196, 182. Okay. Let's copy that. Cancel image equals that. And then sprites. I should really do this at the top. Or at least these 3 lines. Okay. So now the castle can just add itself to the display. So sprite disp.sprites.push castle. Oh yeah, it needs to be on the screen somewhere. We'll put it sort of in the upper right corner. So castle.x equals, I don't know, 700. Castle.y equals 50. Okay. I want it a little bit lower down and a little bit further to the right. Here's a fun way to position exactly. While true, castle.x equals mouse.x, castle.y, mouse.y. Oh man. I said it, but I didn't type it. Field and y. So let's say we want it like there. 786 and 504. I'm going to round those a little bit. 500 and 780. Cool. Okay. So we've got I can no longer drive. Why can I no longer drive? I think our player's no longer, no, the player's definitely there. Is this player getting added anywhere? Nope. I guess somehow I deleted the code that was adding. Oh no, it's right here. Ah, but the player isn't the right player. That's the old stale player. So we're going to do that down after creating the player. Like so. Oh man. It's embarrassing. Okay, so there we are. Oh yeah, and we're going to have to tint these. Oh, and we should also think about layering. Well, actually, maybe it's okay. Because if the castle's meant to be like towers that rise up into the ground, you'd expect them to go cover the player. Okay, and we should tint these. One side will be green, the other side will be orange, because those are easily distinguishable, even for people with abnormal color vision. But let's make some constants. So, friendly color, our color, player color. I'm going to use all caps for constants. How about slightly bluish green and enemy color equals 0, nice orange. Good enough. So player.tint equals player color, and we'll do the same for the castle. Hey, there they go. They look nice. All right. So what's the next step? We could try to get some enemies coming in, crawling towards the castle. And then we would need a damage system for both the player and the enemies, ultimately for the castle. Or we could do the bit where you can lay down towers and such to defend your castle, but I don't think that is as much fun. So let's try to get some enemies in. I think we've got maybe 15 minutes left. That should be enough time. Sure. I'm going to say for sp in sprite disp.sprites sp update. So we're going to update all the sprites. Everything needs an update function, which means our castle even needs an update function, which it will want later. For now, we can just say null, and that works fine. Enemy class. All right. I'm going to capitalize enemy because this is going to actually be a class with multiple instances under it. But it's still going to derive from sprite. And for now, we'll just set the image at this level as well. So we can do unit sprite image, and we'll have tanks come in. We'll do that same one I did before. So that was, what was that, column? I can't remember. Column 1, row 2. Unit sprite image. 1, 2. Enemy tint equals enemy color. Okay. Great. Oh yeah, and while I'm at it, I think all of my sprites are too big. I'm not 100% certain that that's true of the castle. Might decide the castle's fine the way it is, but I definitely want to shrink the player down and the enemy units down so that we can fit more of them on the screen at once. We could scroll, of course, but I think it's nice to be able to see what's going on the whole battlefield. So I'm going to try to avoid scrolling. Keep a list of enemies. Let's see, 760 times 90. This is just picking a random position along the horizontal range of the screen, and we'll start the vertical position down at the bottom of the screen, and then we need to do sprite sprites.push enemy, and also enemies push enemy, and our enemies are going to need an update method. All right, which we will fill in later. Too many arguments on line 78. All right, line 78, what's the matter with you? Oh, I forgot my assignment. All right, cool. There's our little enemies. I dig it. You know what? I'm going to give them some random dispersion. And I think this is good size, too. Give them some random dispersion in Y as well. Alright, so there they are. They come in. And I'm going to have them face up by default. Alright, so it looks like they're coming for us. That's exciting. Now, how do we want to do that? You know what would be handy? No, we're good. I was going to say like a general sprite turn towards method, but no, we'll do this on enemies, and it's not the same as how the player moves, so it's fine. When we have friendly units, which we might have eventually, we can make a common base class for enemy units and friendly units. But for now, we'll just do it on enemy. So I want the enemies to pick a target, and it's going to be either the player, if the player is sufficiently close, or the castle. And then I want them to chase that target. So that seems like a pretty good goal. Enemies. So enemy that target equals castle. All right, so update. Let's see, player disk equals, have to kill that distance between self and player. Castle disk equals if player disk is less than, I don't know, let's say 100, then select that target player, else select that target just castle. Okay. Pick the target. Chase target. So we do that by, let's see, target angle equals a10 again. Target.y minus self.y and target.x minus self.x. And you thought algebra was never going to come in handy. Use it all the time. Okay. And then we want to move towards, and we can use our move towards angle thing. So self.rotation equals move towards angle. Went to all the trouble of working that out. So going from self.rotation towards target angle at most 5 degrees per frame, and then move forward. And moving forward is very much like this. And I am a little tempted to make this a general method. Sprite extensions, sprite.move forward, this function, speed equals 10. All right, so we get the radians of our rotation, and then we add to x and y, again, using the little trigonometry. Okay, so now the player can say move forward, and enemies can also say move forward. Self.move forward, self.speed, and I want enemies to have a speed as well. Enemy.speed equals, gee, I don't know, 5, similar to the player, or maybe a little bit less. Save it, run it. Undefined identifier target, 98. Yeah, that would be true. I need to say self target. Oh, whoa, there they go. Look at them. They're just running right off the screen. They're like, forget this, I'm out of here. All right, where are you guys going? Enemies, 0. Let's pre-print that. Its target is a castle. We probably just mixed up radians and degrees again. So easy to do. The target angle equals the a tangent of this times, that's in radians, there's 180 degrees per pi radians, so there we go. It's kind of a long line. We'll break it up like so. Okay. Hey, now they're all going towards the castle, but you guys come towards me. Oh, this is exciting, actually. Come here. I'll try to kite you guys away from the castle. But if I go too fast, they're going to be like, forget it, we're going for the castle. Come here. Come here. No, you get away from the castle. Yeah, come over here. No, come back. This is surprisingly fun already, and there isn't even really any game to it yet. Now, obviously, there's no collision between units. These guys I'm kiting right now, that's like 3 of them on top of one another. I wonder if I can get them all on top of one another. Oh, yes, I can. Oh, so that's not great, but in the real game, I don't think it'll matter because there'll be so much chaos going on, units taking damage, quickly getting killed, that there's not going to be time for them to get much in the way of on top of one another. The other thing we could do is we could vary their speed a little bit, which is fun because it makes each of the units seem a little unique. So we'll do enemy.speed equals plus equals random minus 0.5. So now they're all a little bit different, and even if we were to try and get some on top of one another, they're going to separate, right? Because they're not exactly the same speed. Okay, that's fun. Alright, next damage. What time is it? Oh, you know what? I hate to say it, but it's probably time to call it a day. I think we've gotten a lot done today. I'm feeling pretty good about it. So, let's just take a quick look at the code and review. From the top, we import a couple of things. We clear and reset the displays, get a reference to the standard sprite display. We set up our constants, which right now are just the colors. We load our sprite sheets and make a utility function for getting a particular unit out of the unit sprite sheet, and for plucking the player image out of that same sprite sheet because it's not quite like the other units, because it's bigger. Then we have a section of utility functions. I spent way too much time working out this move towards angle function, but we finally got it. That's a handy one. Should write that down. Then we made a sprite extension to move forward. This was pretty simple, but because we needed it in more than one place, a good principle is always do not repeat yourself. And so we moved it into an extension method right on the sprite class so that we can use it for any sprite. We have the player sprite. Its update method is mostly about getting inputs, figuring out what direction the player wants to go, and turning towards that using our handy move towards angle, and then adjusting our speed and moving forward. And that's it for the player at this point. We added a castle class. It doesn't do anything right now. Its update method is null, but it sits in the corner and it looks important. And then we added an enemy class, and its update method picks a target based on how close the player is, and then it chases the target using that same move towards angle function and our move forward extension method. And then we created a bunch of enemies, threw them on the board, drew a nice little grid background, and our main loop is at the bottom, and it's super simple because it just updates each method. So I feel like that's a good start for today, and I'm going to leave it at that. And next time we'll work on adding actual combat between these units. So whenever the player touches an enemy unit, maybe, and is facing it, it does some damage, and vice versa. And the idea is that the player unit is tough, but there's only one of it. The enemies will be weak but numerous, and so you have to run around trying to take out these enemies before they get to your castle. And when they do get to your castle, they will damage it, and that's what it's all about, making sure that your castle survives each wave. So next one should be really fun. Tune in then, and if you have any questions or comments, leave them below, and I will endeavor to read and answer every one. Until next time, happy coding!